everybody. It looks like people are needing a little help with homework 13, number 4. So what I thought I'd do is give you a little insight into that. Let's assume that we're going to start off without the drawing of the state diagram, and instead what we'll do is we'll create the present state, next state table. And as I recall, that's ABCDEFG. And then because this is a mealy machine, the outputs are a function of the inputs as well as the present state. And so if you like, what we'll do is we'll write out the next states first. So that's E, G, D, F, E, C, D, F, and then C, nope, that's G, F, and then B, D, and then E, C. Now, if you like to sort of make sure that you've got this correct in terms of next states and what works and what doesn't, you've got to write out the outputs for each one of the next states. And the way you do that, right, you can kind of go back to the diagram if you like. What I'll do is I'll give you a little brief insight into that. The diagram shows us that we've got a transition from A to B. Let's see if we got that right. If you're in if you're in B, you can go to D, or you can go to F, and in the process, when you look at it, I think we can draw this somewhere. Here it is. It says B, there's a D over here, and there's a transition to D, and then there's another F over here. There's a transition to F, and what it says in the transition to D is it says 0 stroke 0 or 1 stroke 1. And what that means is that if there's a 0, you transition to D and the output is 0. If there's a 1 on input, you transition to F and the output is a 1. And so that's why we write the 1 in there, because of the 1 down in here. That's the output. So continuing now. So for example, if you see D and you're looking for the next state, D shows us that it can transition back to B, that the input must be 0 and the output must be 0. And so we write in here B. And so when we're starting to think in terms of what the present state, next state diagram represents, it's really just a shortcut for the finite state machine diagram. But it's a convenient one, and you really have to do that mapping properly. So once you've got this written out, what you need to do is you need to create an implication table. B, C, D, E, F, G. And then you start with the first letter and go to the penultimate letter, A, B, C, D, E, and F. And then what you do is you draw your lower triangular. Oh, what a pleasure to have lines. They don't give you lines on the whiteboard. You do the lower triangular matrix. And now you proceed to trivially eliminate all those elements which must be different based on outputs being different. So if 0, 1 is different from 1, 0, then you know that A must be different from C. So when you go to AC, you put in your X. In fact, you know that A must be different from C, and F and G. And you can do all of the X's at once. You also have to know that B must be different from C, F, and G. So you put in the X's here. You also must know that C, right, we're up to C, must be different from D and E. So you put in the X's here. You also must know that D, that's here, must be different from F and G. So you put the X's here. And you also must know that E is different from F and G. And F might be the same as G, we don't know. And so that's what we get so far. So next thing I'd like to do is start by looking at the A-B transition. From A to B, I go D-E, G-F. Now when I look at D-E, I wonder, is D-E allowed? I don't know. Could that be the same? Maybe. So let's compare it. I go BG, and I know F and F are the same, so I just write BG. So then I wonder, is BG okay? No, it isn't. Aha, so that gets eliminated. And since that's eliminated, then this must be eliminated. And so now I've gotten a little backtracking done, and I can go to AD. AD is going to be from here to here, that's PEGF. And now, if I'm interested in BE, I can look that up, and I see it's blank, so let's look up BE. It's DG, and then FF. So now I can look up DG. I see there's an X. That means BE gets an X. And so I've eliminated another couple of state transitions that might not be trivially equal. So now, or in fact, they are distinct. So let's look at AE. AE, that's EG, FG. Now, if I look at EG, EG is already an X. Let's just make sure that's right. EG, that's E to A, right? AE is EG, GF. Yeah, that's correct. And so then this must be E to G, and E to G is definitely going to have an X in it, so this must have an X in it. How about C to F? Let's do B to D. B to D, that's a good one. So BD is D to B. Well, that's the same. And F to F, so that's trivially identical. BD. How about C to F? C to F, that's going to be, that's an E. C to F is BE, CD. So let's look up BE. BE's been eliminated, so we can eliminate that. Now here comes CG. C to G, E to E, that's the same. C to C, that's the same. Looks like CG, CG are the same. So at this point now, I can say that C equals G and B equals D. And when you do something like that, what you can do is you can modify your diagram by saying, well, let's remove G. and every place we see a G, we'll put in a C. And then it says here B equals D. Okay, so let's remove D. And everywhere we see a D, we can put in a B. So now if we look at our next states, there should be no more G's, there should be no more B's. And if we rewrite this, and I suppose we could, let's see if we can find a little space to rewrite it. Well, it's not so easy under the camera unless we start moving things around a little bit. If we rewrite it, it becomes A, B, C. We skip D because we remove that. E, F, and then we skip G. And then for x equals 0, x equals 1, we can write out E, C, because we replace G with C, B, F, E, C, C, F, B, B, and then the output for x equals 0 and x equals 1 must be equal to 0, 1, 0, 1, 1, 0, 0, 1, 1, 0. All right, so the output here hasn't changed. The output on E hasn't changed. The output on C is the same. Output on B remains the same. Output on A remains the same. We would expect the outputs to be the same. And this is your answer. And that is a legitimate answer for one of the questions. I think we're calling this question 4. And I believe it's the second answer in a row. Let me just check. It is exactly correct. So this matches one of the choices. I know some people said they couldn't get that, but it is working. And I thought you'd like to see that. Talk to you later. Thank you. Bye.